Hi, hello folks. Welcome to our next video in the playlist of Google Earth Engine for the land cover applications. So in today's video, we're gonna detect the urban bodies in any of the urban areas. In today's video, we're gonna see how we have the built-up structures which are made in the region of Bangalore. So it's a capital city of Karnataka. So basically, we're going to detect whatever the built-up structure is there, like roads or the buildings or any other impervious layers, so which are present on the land cover. So we are going to using a simple index called a normalized difference built-up index. So NDBI for short. So in a remote sensing, it is mainly used to map the built-up or the urban areas using a satellite imagery. So basically, we will be using the Sentinel-2 image. So the formula for calculating the normalized difference built-up index is that we need to get a normalized difference between the short wave infrared and near infrared band. So the short wave infrared is a B11 in case of Sentinel, or you can also use the B12, and near infrared you can use always the B8 band. So how we are going to interpretation of this normalized difference built-up index is that its value ranges from -1 to +1. So whether the NDBI value is near to the positive, it means it's an urban or a built-up land. So if it has the lower or the negative values, then it indicates that it's a vegetation, a water body, or a bare soil. So let's just getting started. So let's search our main important Sentinel-2 dataset. So I'm gonna import the surface reflectance S2, and I also want to have the shapefile of the Bangalore. So I'm gonna import it from FAO Global Administrative Unit layer, the second level administrative division, because it's a district. So you can rename it as FAO, and again you can search here Bangalore so that I can have my point of interest. You can check this and you can rename it as point if you want, or let it be geometry. So now I'm creating one more variable called ROI. So this stands for my region of interest. I want to filter my FAO dataset for my point of interest, that is Bangalore. So use the function filter bounds to point. So that's it. My region of interest is ready. So you can add this to map with the help of map.addLayer ROI, and you can style it with the help of .style function. So give the parameters. I want the color, which is an outline, to be black, and my fill color to be transparent. So I'm using the octocode for the transparent color. So you can leave the visualization for default, and you can have the layer name as ROI and click on the run. So you'll get the shapefile of Bangalore urban district, beautifully located with the transparent background. So you can also, if you want, you can switch to satellite mode with the help of function map dot set options to satellite. Yeah, so every time you don't need to switch to satellite mode. If you run the script automatically with this function, you can have the base map to be satellite. So you can also have multiple base maps. So if you can just go to set options, here you will find map.set options. You will find the options which are available for having the base map. So here you will find you have the road map, you have the satellite mode, you have the satellite hybrid mode, and the terrain mode. So you have the four types of base map in the Google Earth Engine, so which you can use by default. So now my region of interest is ready. Now I want to have my pre-image with the filter. So I have my Sentinel-2 dataset. I want to filter it down to bounds to my region of interest. Also filter to date. Let's say I want to filter it for 2025. So you can use the 2026 as an exclusive date because the 2026 is not included, so that whatever the images will be of 2025. So I also want to filter the cloud cover. So with the help of function e dot filter dot less than, so give the property which you want to filter. So the property name is cloudy pixel percentage. So this should be less than 0.1%. So my filtering is ready. Let's just print this pre-image to see how many image collections are available. So I have 23 elements with less than 0.1% of cloud cover for the year 2025. So here you have the date starting from 2025 January 22 to 2025 April 17. So that's the last date when we have the low cloud cover. So after that it's rainy days. So the probability of having the less cloud cover after that is quite difficult. So I have my pre-image done. Now I want to have my image scaled. So remember Sentinel to always have a scaling. So you need to multiply each of the pixels with a scale value of 0.0001 in order to have a meaningful values at your image. So I'm creating one more variable called image. So for my pre-image, I'm mapping a function. So you just use the function dot map and create a function which will take image as an input and also return the same image, but it should be multiplied with 0.0001. Yeah, so after that you would get the median composite of it and click to your region of interest. So now if you just print the image, you have 26 bands with a single image. So you have all these bands. So if you want, you can also filter these bands. So just come here and put dot select v dot star. So this is this function will select only the bands starting with the name B, so that you have only the bands which have starting with the name B, B1, B2, B3 like that. So till B12 you have the bands with the scale value from 0 to 6.5 and the coordinate system is 4326. So now my scaling is also done. So let's just create one more variable called normalized difference built up index NDBI. So for my image, use the function normalized difference between the shortwave near infrared. So B11, or you can also use the B12 and B8. So if you have any kind of doubts, you go to the Sentinel-2 dataset, go to bands and scroll it down. You will have the band's name here. So B1 to B12 is the shortwave infrared, and at the B8 you have near infrared band. So my NDBI is ready. So I want to rename again because I want to have the proper band name. It should be NDBI. You can also use the caps. So now just print this, print NDBI, click on the run. You'll get a single image with one band where you have the band name is NDBI and it has a float value from -1 to 1 in a coordinate reference system 4326. So let's just add this to map. So have the visualization parameters from -1 to 1 and give the palette. So let's say whatever the lower values are at vegetation. So I have dark green and the neutral values would be white and positive values would be, let's say, gray. So don't know gray does work or not. So can also rename it as NDBI and click on the run. Map is loading. So just stress the values to 100% so that you can have real values. So just zoom in. So if you can see the most of the let's just make red so that we can get a clear combination of colors. Just switch to 100% and click on the apply. So the values ranges from minus 0.4 to 0.232. So let's just adjust this palette. So let it be light green in color. Red and gray should work. So if you have any kind of queries so for the colors, you can always go to a website called Color Brewers. So here you will find the hexa codes for the colors which you want. So I want it to be diverging or sequential. Yeah, sequential would be good. And let it be this color section. So I want my class color to be, let's say I want to have 4 class. So you can just come in here, export. So you here you will find a list of hexa codes for the colors. So you just copy this and paste it in here if you want. So I think this is also looking good. This palette is also okay. Just expand the value and click on apply. Yeah, so here you can see the most of the colors are in red, so indicating the most of the city is urbanized. There is a low chance of having the vegetation cover. So you can also compare to the satellite based map. So if you can just uncheck it, so most of the area is covered with the red color. It means it's a built up area. So wherever you will find green or some kind of light green color, so those are all either bare ground or a area with the low vegetation covers. So I hope guys you have understood how we can get this uh, normalized difference built up index. So let's just also try one of the palette which we have copied from there. So it does look much better, I think. So wherever there is a white color, those are all non-built up areas. So wherever you find an increasing gray or near to black color is a built up plan. So that also looks good. So the previous palette was also good. So you can choose the whatever palette we want from the color brewers. So only this TIFF image with a single band of normalized difference built up index is important to us. You can export it and you can have your cartographic skills in your QGIS or ArcMap, so wherever you are comfortable with. So I hope guys you have understood how to calculate this normalized difference built-up index in Google Earth Engine and how you can export it, visualize it, and interpret it. So thank you for watching. If you have any kind of queries, questions, so you can always post it in the comment section. Thank you.